Okay, hello. I've gotten to a point with the Overmind project where I will actually push where all the pieces are working together. And I'm going to just show you some structure of the project and a little bit of code and also a quick demo of the dev tools. Um, yeah, and I have some beverage here to keep me going. Um, and yeah, so let's just dive into it. So what you're seeing here is the Overmind repo, and it's using repo cooker. And oh, sorry, there was this strange sound. Anyways, um, yeah, so this is the Overmind repo, and it uses repo cooker. Uh, So what we can see here is that we have this packages folder, which holds a demos folder, and a node modules folders, which actually holds the packages. And the current packages is action chain, which manages expressing actions as a chain, like a functional approach to actions. And then we have Overmind, which is the Overmind project itself. And then we have Overmind Dev Tools, which is the Electron application, which is what we used to call the debugger. But I don't want to call it the debugger in this project because it is a development tool. It's not a debugging tool. It can help you with other things than debugging your application. And then we have proxy state tree, which also lives inside this repo. Okay, I'm not sure if we're going to look into any code of uh, action chain. Basically, yeah, I don't think that makes any sense. What makes more sense is actually looking into Overmind. So what's like the key awesomeness of this project is that it's written in TypeScript. It has some pretty amazing typing, like some crazy typing as well to actually make things work. It's insanely difficult to create an API that at this level that really works well with typing. But the second thing is that it's so is that allowed? Like, can I say so much less code? So much, yeah, you know what I mean. Um, it's just super focused and it does exactly what it's supposed to do. And that's because we're taking like all the experience from 3 years of Cerebral, like kind of like what's it called? Like molding it into like this one concrete thing, and then just do exactly that. So there's no history in this code. It's just a very specific implementation. Um, so if we look into Overmind and the main file, it's mostly typing. Like the code for this project is mostly typing, which is kind of insane. So, but I wanted to scroll down here where it actually does something. So when you create an application, it creates a proxy state tree with the state of the application. And then it produces an action chain instance where we just give it the providers and also the state. And then we create an action factory, and this is where we actually create the different operators. So as we can see here, we have mutate, do, map, try, when, filter, debounce, and there will be more here as well. But yeah, as you can see, there's like tons of typing here. So basically, we create the state tree, we create an instance of action chain, we create the operators for the action chain, and then we make sure that whenever an operator is async or an action ends, we flush out the state tree, meaning that if any mutations occurred, it should notify any registered components or whatever is registered. And then we set the actions that you as a developer has defined in Overmind. And then we initialize the DevTools. And the only thing the DevTools does is send the initial state, and then on different events related to firing of actions, it sends that information to the debugger. And at the end, it exposes methods for actually tracking state and, yeah, basically tracking state. So that's the whole thing. That's what it does. And then we have like the DevTools. If you have seen the code for the DevTools of Cerebral, it's insanely big. But this is all it does. It just connects. It sends messages, which it buffers up, and then it passes it along. So the code is super simple here. And then the way Overmind works is that it has like the core project, which doesn't have like a view implementation. It just exposes the ability to track state. So if you want to use like some view layer that hasn't been implemented in Overmind, you can still use it and you can just implement it yourself. And that means that in this React implementation, we are actually just extending the Overmind app, and we're just adding a connect method on it. And this is what's responsible for, and again, tons of typing, what is responsible for implementing the state tracking. And it's kind of interesting how it works, because the only thing we do here is identify if it's a class or a stateless, like a function. And if it's a class, we hijack the render method because we want to start tracking at the beginning of render and then stop tracking at the end of render. So that is what this code does. And then if it's a stateless component, then we just return like a new component, and because it's a lot simpler to intercept like a function because you just wrap it. It's harder with a class because you have to intercept kind of like the render method. But it looks pretty much the same. The point is it's a very simple implementation. Okay, and that's also a thing. If you remember in Cerebral, you don't only have the specific view implementation, you also have this view class, which is massive. But this is all there is to it. Cool. Okay, I hope you're still with me, because I also want to show you the DevTools. I think like the code of the DevTools. Yeah, let's have a little look at how you kind of like define the application. So what I've done here is in the DevTools itself, like the Electron app, what you see and interact with is defined, like the Overmind app is defined here. And the only thing it does is it defines a context, because you need a context with your providers and the state. And you want to define an action type. Those are the only two types related to the Overmind app. And then you want to type the connect. So when you hook onto components, you want to type connect so that when you look at state and actions, you actually see the state and actions defined in your app. But this is all there is to it, actually. And in the state, there's just some state here, which exports some types. Again, lots of types. And then we have the providers here, just plain objects exposing stuff. And then we have actions. So the way, so this is something to explore, of course. I have put everything in one file now. As the application grows, it will probably be different files. Currently, I just call them like tasks. And these are functions that does something, like talks to providers, or just does some, like it's not a mutation, basically. So for example, here we can see that we're using our typed context to go and grab some apps from storage, get current port from storage, get new port from state. We store the apps. We have something called toNumber. And yeah, so it's just tiny simple functions that you compose together. And the same is for the mutations, because the mutations, they should only do something to the state, and optionally they will have a value. So in this case, when we set the apps, we have the state, and it receives a value, which I call apps here, and it should be the apps. And the same for all, again, just tiny functions that does one specific job. And then we have the actual actions here. So what I've done here is that I'm returning, like when you define actions, you do it in a function, which receives the actual action that you use to define the actions. And there are some technical reasons for this, like the way things are combined. But the really good thing here is that you have to type this action. So when you define, like if you were to import action directly from Overmind, that wouldn't be typed. So having this callback is really great for typing, because then you can just add your action type and then it will work. It will know about your state and everything. The second thing is circular dependencies. So when actions are defined in a callback like this, it doesn't matter how you combine or use actions from different parts of your application. You can just mix and match however you want and don't worry about circular dependencies. But anyways, as we can see here, we load the DevTools. It's an action that first gets apps from storage. We're using map because that's the new, like the action here doesn't receive any value. We haven't typed the action, so it doesn't receive a value. But what it does is produce a new value here, which is the apps from storage. And then it mutates by using the setApps function. And then we get current port from storage, and we set the current port, and then we set the app loaded, and then we map to connecting to current port, which is either the current port from the storage or like the first app in your list. Yeah, so the point here is that like this is perfectly safe. If I do any kind of changes here, for example, if for example set error, I want it to be a number instead. First of all, it gives an error on state, but it also gives an error down here because it expects, because I said this action receives a string, but the error expects to have a number. So this was just a tiny example. This is just my VS Code being shit. I don't know, like the typings aren't updating. It's really strange. Anyways, the point is that with this kind of structure, like having all these tiny functions makes it very easy to test these functions if you want to do that. And with the types, you are ensured that wherever you use these functions in an actual chain, you will know if they work, like based on the typings you've done. And then you get all this composability, like you can reuse all these functions in other action chains and all that stuff. But this is kind of like, this is what we want. The question is how to express it. Like in Cerebral, we have signals, which is super declarative, but it doesn't work with typing. And so you do get more readability, like in my opinion, it's more readable at least. But you lose safety, type safety. So if you're building large apps, you will actually get into an issue for sure. But you won't in this kind of implementation. And then you can argue like, yeah, but this is this is not as readable as Cerebral, and I favor readability over maintainability kind of thing, and that's perfectly fine. But then Cerebral should be like a good tool, and then Overmind is like really embraces this like maintainability, common concepts like action and chaining and all this stuff, but uses all the experience from Cerebral to make it work. Okay, I've been talking a lot right now. Let's look at some, let's look at the debugger. Like currently the debugger allows you to add like a port, like an app, and then it's just a console. And this console is very useful for further implementations, but I want to show you like how it works. So I have this silly application here, and if I refresh it and we look into the debugger, we can see it starts receiving events. And this is something that I learned from Cerebral, is that the client was trying, like the Cerebral app itself, was trying to help the dev or the debugger to like build information instead of just pushing tiny like it built these large structures of information instead of just pushing information to the debugger, and then let the debugger handle that information in whatever way it wanted. It was really complex with tons of different complex types of messages, while in this case we're just shoving in information as it happens. So what happened now was that the application loaded, so it passed an init message, and this just contains the state of the application, which we will use to display like the state tree initially. And then we have a component that just said, okay, I just tracked some state, I have the name app, and these are the paths I tracked. That's all it does. And every time that component updates its paths, it will trigger a message and pass it to the debugger, sorry, the DevTools. And then I can try to change something here. I will just type one letter. And now we see more stuff happening. So first of all, it indicated that we started an action, which has an ID, like that's the kind of like the name of the action, the instance of the action. And then you have execution ID. So you might call the action multiple times, and that is when the execution ID will change. And then we started an operator, and we still have the action ID and execution ID to match messages together. It doesn't have a name because I was lazy. I just inlined the code instead of moving the functions outside. And it has an operator ID of 1 because it's the first operator. Maybe that should be 0 based as well. Anyways, the path here indicates if the operator was running on a specific path in the execution, meaning you get like nested execution. That's not the case here. And the type was a map, so it was a map. And then we have operator n, and we can see the result of that operator, which was the h. So it actually mapped a React event, change event, to the event target value, which is h. And then we started a new operator, and this is a mutation. Yeah, because I call it mutate now, but I think it should be called mutation, because you will probably create a file called mutations. So it's kind of, okay, so you do a mutation on mutations dot some mutation. Anyways, details. Anyway, so we're running a mutation here, operator, and then we can see we actually get some mutations. And this just tells us about what kind of mutation it was and what path was that mutation performed on. Oops. And yeah, and by the way, this inspector is actually re-implemented. It's like it's so, again, much less code. it's really, really cool to have all this experience with Cerebral and then just re-implementing stuff. It becomes so much cleaner. Like, that's what refactoring does. It just makes things a lot cleaner. Okay. But this mutations thing should actually also contain like what action ID and everything that's missing. And then that mutation ended, and then the action ended. And then we see that component updated again, because it's like we did a change on new to-do title, so it actually updated. Okay, the point is that it's extremely easy to just push new types of messages into the debugger, and then it's just a matter of collecting them and visualizing them. And there's a ton of awesome examples in the Cerebral debugger on how to visualize these different things. And yeah, I'm like super excited to start actually implementing that stuff. Cool. I guess that's it. I hope this was useful. I will push like the current state of the repo. You should just be able to npm install on it, and then you can go to the different Overmind dev tools with npm start. It fires up everything. And you go to the demo, you just npm start and it fires up the demo, and then you can start to see things happening. Okay, cool. I will create a better video as things gets more on track, like the API itself. I will start to write some documentation for it, like suggestions on the API surface. Like, it's still very new, but all the pieces are now talking together. So it's time to actually start to nail the API. Anyways, I'm rambling. I will talk to you later. Okay, bye-bye.